In this lesson, we're going to revisit stoichiometry, only this time we are going to use solution data to help us solve for moles. So basically, we're going to follow the same steps. We're going to want to find moles. We're going to then use our mole ratio, and then we're going to solve for whatever it is that the problem is asking us to solve. This, by the way, is on page 444 in your Nelson textbook. So here's our first example. It's asking us to determine the minimum volume of 0.50 mole per liter sodium sulfate that is required to react completely with all the barium ions in 250 milliliters of a 0.150 mole per liter solution of barium chloride. So step one is always to find moles. So if we look at our given information, we can easily find our moles of barium chloride by doing our concentration times our volume. We just have to make sure we remember to convert our volume into liters. So we want to use 0.25 liters. And when we do that, we get 0.0375 moles. Step two is to use our mole ratio. So we're going to take our 0.0375 moles of barium chloride. We are going to multiply it by 1 sodium sulfate over 1 barium chloride. That information is from our balanced equation. So our number of moles stays the same. It's important to show that step just in case it's not a 1-to-1 ratio. The third step is to solve for whatever it is the question's asking us. So it's asking us for the volume. So we're being asked to figure out V, and we're given our concentration, and now we have moles. So V is equal to N over C. So we have our 0.0375 moles and our 0.50 moles per liter. So our moles will cancel, and we get 0.075 liters, or 75 milliliters. Either answer would be equally correct. In our second example, we're told that a lab tech has dissolved 15 grams of iron 3 oxide to prepare 150 milliliter of solution. What are the amount concentration of iron ions and oxygen ions in the solution? So remember, we always need to start with a balanced chemical equation when we are talking about stoichiometry. So if we have that solid and we're dissolving it in water, remember water's just the dissolving agent is not really involved, we would get 2 iron ions and 3 oxygen ions. So remember, ionic compounds dissolve to form ions in solution, and we're being asked to figure out our concentration of our ions. So step one is to always figure out our moles. Well, the only way we can figure out our moles here is to do our mass divided by our molar mass. And so 159.7 grams per mole is our molar mass for our iron 3 oxide. So our grams cancel, and we get 0.0939 moles. Step two is to use the mole ratio to convert from our known number of moles. And so that's our moles of iron 2 oxide, or iron 3 oxide, times, and then we're going to start with the iron ion. So we do 2 Fe3 plus over 1 Fe2O3. So our moles of Fe2O3 cancel out, and we are left with 0.188 moles of our iron ions. Step three is to convert to whatever it is the question's asking us, which in this case is a concentration. So we're going to do our moles divided by our volume in liters. So again, we want to divide that 150 milliliters by 1,000 to get 0.15 liters, which gives us 1.25 moles per liter of iron 3 ions in solution. This question asks us to do it for both iron and oxygen ions, so we're going to repeat these steps using the same number of moles, only this time we're going to convert it to oxygen. I'm going to do that on another screen here so that we have a little bit more space. Sorry, that should be a 3, O2 minus. So this time we're going to take, so we're starting really at our mole ratio. So I'm going to put a 2 because we're on step 2. So we're going to take our 0.039 moles of iron 3 oxide. And this time we're multiplying it by 3 moles of O2 minus and 1 mole of Fe2O3. So that way our moles of Fe2O3 cancel out. Oh, sorry. And we get 0.282 moles of O2 minus. Then we're asked to figure out our concentration. So C equals N over V. So we do our 0.282 moles. Again, we're dividing it by our volume in liters. We want to use 0.15 liters. And we get 1.88 moles per liter, or capital M, of O2 minus. So those were 2 examples of how we can use stoichiometry in solutions.